So welcome everybody to this latest video on 162 Maths, and in this video we'll be continuing with the theme of going through some big mock questions taken from some higher GCSE exam papers. Now before we get started, a little reminder that if you want a copy of the questions, then all you need to do is just simply download the link in the description and also include the mark scheme to that. And I always recommend you having a go at the questions before watching through this video as we go through the answers. And I'll also include a copy of the 162 Maths contents page, so if there are any topics that you can see on the screen as we go through some exam questions that you're not too sure about, I strongly recommend revising the topic, and you can do that by clicking on the link in the contents page to the relevant lesson. So let's get started on question 1. So question 1 reads, by completing the square, prove that x squared plus 6x plus 13 is always positive. So for this, like the question suggests, that we need to use completing the square. So what we need to do is we need to factorize this in the form of x plus a squared plus b. Now how we do that? Well, we first set up our bracket, we then have our x, we halve the coefficient of x, which is going to be 3. We have the constant, and then we take away whatever digit is inside the bracket squared, so that's going to be minus 3 squared. Then we just need to simplify, so we've got x plus 3 squared plus 13 minus 9, which leaves us with x plus 3 squared plus 4. Now what we need to do now is just break down the brackets. So this is when x, for all values of x, this will be greater or equal to 0. So in other words, it's always positive or 0, and plus 4 is always positive. So a positive plus a positive, getting confused with my positives there. So a positive plus a positive equals a positive, and 0 plus a positive equals a positive. So therefore always positive. So something along those lines would be absolutely fine. Moving on to question 2, it says rearrange, and we've got p equals 2m plus 1 over 1 minus m to make m the subject. So for this, what we need to do is first of all put this denominator in brackets and then take that over to the other side so we don't have that fraction. So it'll be p multiplied by 1 minus m equals 2m plus 1. Then if we expand the brackets, we get p minus pm equals 2m plus 1. We then want to take all the m's onto one side and everything else all onto the other. So if I take this pm over to this side and then 1 over to the other side, we end up with p minus 1 equals 2m plus pm. Now the reason why I'm doing it that way is to try and keep my m's positive. So then from this, all we then need to do is factorize this right hand side. So we've got m 2 minus p, and that equals p minus 1, and then we just take that bracket over to the other side, which leaves me with m equals p minus 1 over 2 plus p. And there we go. Now again, if you've got a different variation of this, there are other ways of doing this. So you may have a different way of doing it. So it might be worth checking with the mark scheme to see if your answer is allowed. Moving on to question 3, it says here is a velocity time graph for a cyclist for 40 seconds. By dividing the area under the graph into 4 sections of equal widths, estimate the distance travelled during the 40 seconds. So what we want to do is split the area under the graph under the 4 sections. So as it's in 40 seconds, I'm going for sections of 10 seconds. And what I then need to do is then work out the area, or estimate the area of each of these 4 sections. So the area of A we can assume is a triangle, and that's going to be base times the height. So that's going to be 10 multiplied by 3.2 divided by 2, and that gives me an answer of 16. Then if I then work out the area of B, which I'm going to say is a trapezium, So it's the two parallel sides added together, which is going to be 3.2 plus 5.8 multiplied by the h, which is 10, divided by 2, and typing that all into my calculator, I get an answer of 45. Then with area C, that's another trapezium. So area C, that's going to be 5.8 plus 7.4 multiplied by 10 divided by 2, which gives me an answer of 66. And then finally for D, I've got another trapezium. So again, the two parallel sides is going to be 7.4 plus 6 multiplied by 10, all divided by 2, which gives me 67. So all that's left for me to then do is just simply add these four areas together. So the distance travelled is going to be 16 plus 45 plus 66 plus 67, which gives me a grand total of 194 meters. For B, it then says work out the average acceleration of the cyclist during the 40 seconds. State the units of your answer. Well, acceleration is equal to the velocity divided by the distance by time. So here, for the 40 seconds, what I'm then working out is basically going from 0 to 40. Now this may seem a little bit odd, but basically what I'm doing is I'm working out the gradient of that line. So here the total velocity between those lines is 6, because that's the height of that triangle, and then the base is 40 seconds, so it's 60 divided by 40. Velocity is in meters per second, 40 is in seconds, so 60 divided by 40 is equal to 0.15. So the answer is 0.15, and it's going to be in meters per second squared, or you could write the units as ms to the power of -2. Moving on to question 4, let's just zoom in so we can see it fully on the screen. It says simplify fully, and we've got 8x squared plus 4 over 5x multiplied by 3x over 14x squared plus 7. Now when multiplying fractions, all we do is just multiply the numerators together and the denominators together. So here what I'm going to end up with is 3x multiplied by 8x squared plus 4. And then on the denominator I'm going to end up with 5x, and I've got 14x squared plus 7. Now once you've got in this format, you can simplify where you're going to go. So for me, I'm going to go into, again, we could simplify now, or we could expand the brackets. All depends on whatever you're comfortable with. Let's go for expand the brackets out. So here we end up with 24x cubed plus 12x over 5 times 14, which is 70. So it's 70x cubed plus 35x. So then from this, what we can then do is we can then cancel down. So here we can simplify the top as well. We can factorize it. So let's go for 12x. Then we've got 2x squared plus 1. And then factorize the denominator, in which I can get 35x as a common factor. And then again, I've got 2x plus 1. And then from this, my brackets cancel with each other. The x's cancel each other, so what I'm left with is 12 over 35. Does that simplify? No, it doesn't, so there is my final answer. Moving on to question 5, it says here are 2 square-based paving stones. The stones are similar solids. The price per centimetre cube is the same for both stones. The price of the larger stone is £17.50. Work out the price of the smaller stone. So for this, what we've got, this is similar area and volume. So here we know the lengths of the corresponding shapes. So the length scale factor is therefore going to be 25 over 20, which simplifies to give me 5 over 4. So that therefore means that the volume scale factor is going to be 5 over 4 cubed. Then from this, what we can then do is use the price of the larger stone. So the larger stone equals £17.50. So to get from small to big, we multiply by the scale factor. To go in the opposite direction, we divide by the scale factor. So here, to find the price of the smaller stone, it's going to be the price of the bigger one, which is £17.50, divided by the volume scale factor, which is 5/4 cubed. Now if I type that all into my calculator, I get an answer of £8.96. Moving on to question 6, it says Rick borrows £1,500 from a bank. He pays £100 each month. The iterative formula works out the amount he owes at the end of each month. And it says work out the amount he still owes at the end of the second month. So for this, what we need to do is, first of all, work out what A1 is. So to work using the formula, we've got 1.02 multiplied by the previous term of A, which in this case is 1,500, and we take away 100. Now if I type that all into my calculator exactly how it is, I get an answer of 1430. Then to work out A2, which is what the question is asking me to find, I then use the formula again, but this time for my AN value, I'm going to use the previous value, which is now 1430, take away 100. And again, type that into my calculator, I get 1358.6. So that in money terms is 1,358.60. Moving on to question 7, we've got a functions question. It says g of x is equal to a times b to the power of x, where a and b are constants. G of 0 is equal to 8 and g of 3 is 343. And the question is asking us to work out the value of g1. So what we need to do first for this particular question is substitute these numbers into this formula. So here what we're going to end up with, if I just call this 1 and this one 2. So here we've got g of 0 is equal to a times b to the power of 0, and that equals 8. Well, anything to the power of 0 is just 1, so that means that a equals 8. So that's one of the variables I've then found. Then using 2, let's just label that one as 1, we get g of 3, where I substitute x equals 3. So here I've got a times b to the 3 is equal to 343. Now I know that a is equal to 8, so I can substitute that in. So I've got 8 times b cubed equals 343. So therefore b cubed is going to equal 343 divided by 8, which leaves me with an answer. So b squared equals 42.875. And then square rooting that, I get a b value of 3.5. So now using these a and b values that I've then found, so the formula is going to be of g of x is equal to a, which is I've worked out as being 8, multiplied by b, which I know is 3.5, and that's to the power of x. So let's just stick a little bubble around that. Now the question is asking me not to find g of x, it's trying to find what g of 1 is. So here g1 is going to equal 8 times 3.5 to the power of 1, which when I type into my calculator gives me an answer of 28. Then moving on to our last question, it says VABCD is a pyramid with a horizontal square base. X is the center of the base and X is vertically above X. And it says BD is equal to 18 and the angle VBX is equal to 72. And the question is asking me to work out the length of VB. Now with these questions, it's always important that you first establish what it is you're actually trying to work out. So I'm trying to work out what this yellow length is. Now from the information that's been given to me, I know that B to D is equal to 18, which therefore means that X to D is going to be halfway, so that's going to be 9, and X to B is also going to be 9. So if I take this triangle out here, and just label that. So I've got V, X and B. So from the information that's been given, a yellow line is what I wanted to work out, so let's call that X. VXB is a right angle triangle. The base of X to B I know is 9, and I also know that the angle VBX, which is this angle here, is equal to 72. So using this triangle, what I can then do is right angle triangle. It's going to be using trig. So here I've got the adjacent, which is 9, the hypotenuse, which is X, and I've got theta, which equals 72. So which trig ratio uses A and H? Well, that's going to be cos. So I've got cos 72 equals 9 over X. So then therefore, doing a bit of rearranging, we get X equals 9 over cos 72. So therefore, X is going to equal, on the calculator, 29.1246, blah, blah, blah. So I'm just going to round that up just so it looks a little bit nicer. So we round it up to 29.1 degrees, and that's to 1 decimal place. And there we go.